John's Facebook page.
Okay, here we are again for our final night of new material. Finishing up statistics. All right. So any questions before we get started? I'm just going to show you the calendar here. All right, this is today, finishing everything up. Oh, that's not yours. This is. Oh, that's not yours. All right, so important dates. We are looking at our final test in 1 week. All right. And then the final exam, Wednesday, May 1st, 6 to 8 p.m. Notice that that's a different day than when we usually meet because classes are over with at that after the 29th.
Mr. Cruz, are you going to open up any of the activities? Reopen them?
On 020, they stay open until today. On Math 120, you know, you can still work on the path as well, but you know, the dates are different in that. They were time dates, pacing dates in the 120. In the 020, like I said, they stay open until the very end,
The
but it
old,
creates a big headache.
Mr. Cruz, the O2, like the rest of the assignments, it keeps saying it's locked. When I try to get on it, it keeps saying that it's locked
In 020 or 120?
in O20.
Well, this is the way you go through, okay? Let me just show you. All right. Because you want to go through, and I got to do a student. Oops, that's not the right thing. Because you're going through Canvas, right? When you're trying to do
Yes.
that?
Mhm.
Well, you don't go
Yeah.
through Canvas.
I
Go through Alex.
Alex. I go through Alex, but every time it's like saying it's locked. So I don't know if
Well,
I'm
this is the
doing
way you
something
go through
wrong.
here. You go through here. All right. I got to show you as a student because mine's not a student account. But you go through. You go through here on Learn. If you go through there, you don't run into that lock problem. See, this puts you where you're at. All right. Just go through Learn. All right. You never lose anything out of the path, but you go through Learn. I don't know what you're seeing that locked. I've had students tell me that, and then I'll show them to do this. And then, like I said, this way you're always going to be in there. So see, it's
Okay.
giving me stuff
Okay.
going
Well,
all the way back.
I'll go that way. I'll go that way.
Because they're not individual assignments. It's a path.
I know that. I mean, I know that, but every time I'm like clicking on it, it's like
Yeah, don't
it's
click on
saying
the
it's locked.
individual ones. Go through
Okay.
Learn.
All right.
All right. Anybody got any other stuff? We'll have some time afterwards. I'm probably not going to take the whole time on this. But as I said, it's not really that much left. All right, and we are recording. So let's go over here to the notes and look at something. All right, so there's this thing called the empirical rule, and this is what I'm going to be using in a second. We may have talked a little bit about this last time, but basically what the way it works is within one standard deviation of the mean is right smack dab in the middle. See that big hump right there and the line there? There's mu right there. That's the mean, the middle. It's also the median. One standard deviation above, go down one standard deviation. And remember that standard deviation, it's what we spent time calculating last time. And so within one standard deviation of the mean, see that red part? 68%. If we go out to the blue line, 2 positive, 2 negative, it's 95%. And then 3 standard deviations, which is almost all of it, is 99.7. So those numbers are going to be used here in what we're doing. Called the empirical rule. All right, so here's a nice problem for us. All right, so this right here is a normal curve, much like what we just looked at. And they want us to fill in the numbers given the information that's up at the top. All right, let's read what they've got. The heights of 8th graders are modeled using the normal distribution shown below. That normal distribution means it's got that symmetric shape. Some people call it a bell curve. The mean of the distribution is 59.1. And they don't let me select that, but that's it right there. There's your mean. And then the standard deviation is 1.2. Okay, those are the two numbers I need. What do you think the mean is going to be at?
The middle.
That's right there in the middle, 59.1. All right. Now, remember, there were 3 standard deviations. One is kind of like a good chunk out of the middle. Then we go out to where the blue one's out. It's 2 standard deviations. And then all the way out is 3. Now, if we look at this one, we'll notice it looks like it goes almost all the way out. See that? So I'm thinking that's 3 standard deviations, but let's check. All right. We're going to take 59.1 and then we're going to add 1.2 to it. And that would bring us up right here, but there's no box right there for the fill in. So let's go out another one. So that would be 61.5, right? Smack dab right in here somewhere. And then we'll add one more 1.2. 62.7. And that's what's going to go there. That's 3 standard deviations above the mean. All right. And then the same thing we're going to do down here. Now we're going to take 59.1 and we're going to subtract 1.2. That's going to take us right around here, 58. But that's not where the box is at. Let's see if we can get down to where the box is at. 56.7. So that's about right here. So it looks like it's one more, just like it was on the top. And that's pretty normal that happens. There will be 3 on each of the side. So 55.5. All right. So according to that we just looked at, that's 3 standard deviations, which is 99.7. So there's what we're looking for. All right, now we got plenty of time. So any questions about that?
You added them 2 together?
What 2?
55.5 and 62.7. That's how you came up with 99.7?
No. No. Let me show you. Let's back up. So 59.1, and then that circle number right there. See it? 1.2?
Yeah.
That's our
Yeah.
standard deviation. That's the size. And we're going 3 of them.
I got
So we're
that.
going to add 1.2 plus, and then that would be right here. So see 0.3.
I follow you.
That would be right where that's at, 60.3. Then we're going to add another one. Oh, I messed up.
Oh my
59.
calculator.
Yeah, I wasn't looking at it. I was looking at the screen, and I'm trying to do 3 things here. All right, so let me put 1.2, and I'm going to store it in there now. 59.1. 59.1. I'm going to add 1.2. I'm going to add another 1.2. That's the 61.5. It'd be right in here somewhere. And then I'm going to add one more. And so that's what I've got labeled there, 62.7. And then the same thing's going to happen over here, except I'm going to subtract from the mean, which is 59.7.
Okay. I got lost after you added, after you subtracted the time.
Here's another one. And that's the 50. Oh, hold on a second. Let's make sure I got this right. 59.1 minus recall minus recall
57.9.
minus recall. So that's right. That's the 3 standard deviations right there. So the same thing here. We got 1, 2, and then there's the third one. And 3 standard deviations is the 99.7. So that's how we know that it's the 99.7, because we calculated adding 3 standard deviations on the right and subtracting 3 standard deviations on the left. All right. All right. Any other questions about this one?
0.5 plus.
So no,
The
that's the,
99.7 just comes from previous information.
it
Okay,
comes from the empirical rule, which is what
Right.
I showed
okay,
you
thank
first.
you. Okay,
And it mentions the empirical rule in there, see? Did I already close it? Yeah, see? See up here? So that's how you know what you're using, those 3 numbers. Some of it, books call it the 68, 95, and 99.7 rule, but it's usually called the empirical rule.
it's too late. My head is not thinking.
Mine is
Yeah.
it's the same way.
Using
I need to get a new
empirical,
head.
using
Yeah, at
empirical.
this time of the semester, my brain just turns to mush. I can't even think straight. Let me go back over and get that little file again. I don't know what I did with it.
Empirical rule.
Yeah, but I had a little created a little
Empirical
this
rule
one.
itself is 99.7.
What's that?
I was saying, I'm looking at the book. The empirical rule itself is 99.7%.
For 3 standard deviations. In other words, if you go 3 standard deviations, that's almost all the data that's underneath that curve. So that's how we can know that if we just walk 3 standard deviations to the right, 3 standard deviations to the left, we've got 99.7% of the data, which for all practical purposes, all of it, all of the data underneath that curve. There's a little bitty piece underneath there, but all right. So let's look at this next. Good thing about Alex, it's got some nice graphics. So this one, it's asking us to shade. This is the standard normal curve. And they want us to shade the region underneath the curve to the left of Z, and these are Z here. These are Z scores. That's what standard deviations are called typically, is Z scores. So Z is equal to negative 1.5. So what I'm going to do is I'm going to select this middle one here. That's going to give me a line. And I'm going to go over here to negative 1.5. Does everybody see how that's negative 1.5 right there?
Yeah.
See that bottom
Yes.
axis?
Yes.
All right. So that line represents Z is equal to negative 1.5. Now, here's the thing we got to watch. They want us to shade the region under the standard normal curve to the left of that. Which side is to the left? Here or
Three,
here?
yeah. What a three
This is
at?
the right.
2 and
The
3.
left is over there. So what we're going to do is just shade that in. That's A. That's part A. All right. Any questions about that? So what that's doing is it's showing us the region underneath that whole curve. Now that whole thing underneath there, remember, it's close to 100% or 99.7. So now what we need to do is, and we can do it two different ways. I'm going to show you both ways for B. We can use this table that pops up when we click on that. See that little link right there? So see this link here. This table. All right, if you click on that, this pops up. Now we got to find negative 1.5. And you'll notice too, they give us just a general picture of that graph showing us that the table is giving us the area to the left. So all we're going to have to do is find that negative 1.5, which is right here. And that tells us that the percentage is 0.0668. It's a little bit less than 6%, 7%. But they want it as a decimal to 4 values. And with this calculator, we can just copy it basically and paste it in there because that's the answer. Because this table is to the left. Because that blue side is on the left of the Z, the little Z right here. All right. Or you can use this fancy little thing. I like this thing. So I'm going to select the one right in the middle. It's right below the cosine, right next to your combinations. Now I'm going to put in there negative 1.5. All right. And I'm going to hit equal. And look at that. It's the same value. It's just not rounded off to 4 like the table is. So you have to round it if you use this. And in this case, it's just lop off everything after the 8. All right. Any questions about that? I don't mind going back over it. I don't mind explaining it again. Because I want to make sure you understand this. Because this is really the key to everything in chapter
Can you explain it to me?
11.
Came back in shortly. Can you explain
So
to me?
you have, all right. So you see this right here? Z is equal to negative 150, 1.5. All right. So what I did is I used this little vertical segment thing. That's just a straight vertical line. And I put it right there where negative 1.5 is. You see where my little cross is at, crosshairs? So you press there, and that makes it, I'll tell you what, let's erase the whole thing. Do it again. So there's negative 1.5 right there. And I'm going to click, and that makes the line. Now, it says shade the region to the left. So then I pick that, and I come over here, and I do the left. Now, in the calculator, I'm going to just put in negative 1.5. And then that gives me the answer right there. And that's what I have. You can also use this table. And as I said, it's got all of them in here to the left. So we go down to negative 1.5. And look at that. Same value. You can't go wrong here. As a matter of fact, if you look at both and they agree, that gives you a sense of comfort that you've got the right answer. Does that make a little bit more sense? We're going to
Hmm.
do this again several times. So, but I
Okay.
wanted to show you on this problem because it's, you know, it's got the graphical effect because we won't always have that to let you see it. All right. So let's see what else we can do. All right. So now they don't give us anything graphical. It's just two parts, and they tell us a couple of important things. We're going to either use the table or the Alex calculator to do this, but here's the problem is, and I guess I'm going to go over here and bring up this little thing because I don't draw too well, and this little thing will make it easy for me to draw it. All right. So I'm not, you don't have to use this. I'm just showing it to show you graphically what's going on. Now it says here, and we got to watch the difference. It says find the area under the normal curve, but this time it says to the right. All right, let me show you how that's different. All right. Negative 0.45. All right. We'll put it here too. Now, if it said to the left, that would be the value that comes from the table and from the calculator. Below, to the left, fewer than, several different ways of saying it. But this one asks to the right. Now, the sad part is the calculator only brings back what's to the left. So how do you think we could find this value here that's shaded if we know this? Well, let me show you. To the right is 1 minus probability of Z to, I'll just write 2 to make it simple. All right, that's the complement rule. 1 minus to the left. So let me show you. All right, so I'm going to go ahead and I'm going to use the calculator to do it. So because it's to the right, I got to use the complement rule because the calculator only brings back what's to the left. The table only brings back what's to the left. So I'm going to use the complement rule, 1 minus, and I'm going to put 0.45 in there. And it was negative. All right. So that's going to be 67.63. Now, remember, that's to the left is about 32%. So the right is about 60, almost 68%. So see the complements of one another? So to
Yeah.
find this one here, we say 1 minus this part. And that's what that's saying right there. To put it formally, you know, it would be, you'd put it like this. Is less than negative 0.45. Okay, so in the calculator, let's go back and do it one more time. Okay, that's it right there. See, to the right is 1 minus the probability of Z is less than negative 0.45. So let's hit equal. And we're going to do 4. No need to round anything. So there we go. All right, now this one is different. They're giving us 2 z-scores, and they want the area in between now, between these two. Let's go over here, back to that little thing here. And I'm going to put in those values. Negative 2.68. And negative 1.19. All right. I'll tell you what, I should have put it over here because it's got a between.
Mr. Crew,
Mm-hmm.
we got access to this graph you using?
You can use it. It's just that it's on the internet. You can use it.
Okay.
I can put it. It's in the notes. Look, but I'm only using it, for the studying part. You're not gonna be able to use it on the test. But anyway, see that right there?
One stack book, okay.
But all you gotta do is go to the notes, and then you can click on it. But I think it's a good thing for people that like the visual aspect to it, and lets you figure it out. So the between is way over here to here. So there's the negative 2.68 to 1.19. Now, the way that we handle this is like this. Between all right, we're going to subtract. So this is the larger one here. It doesn't look like it because it's negative, but that's the larger one
That's closer to 0.
because it's up here. So it's going this way, even though it's negative. Remember, numbers on the left-hand side of the axis work the opposite as they do on the right-hand side.
Subtract. Okay.
Now, so let me just kind of write it formally, and then we'll put it in the calculator.
Oh,
So the probability of negative z is less than negative 1.19 minus the smaller one, which is z is less than negative 2.68. You can do it by hand if you like. You just look up each one of these. This will be the larger number here. And then the one on the right will be the smaller number. All right, so let's look at the calculator. You can do it with a little table. All right, so I'm going to type it in pretty much just like it
I can't
is.
see the calculator, Mr. Crew. We can't see your calculator. Thank you.
What's over here that you can't see? It just,
You?
I don't know. I thought you could see over there.
You?
Oh, well, I'll just keep it over here.
Thank you.
All right, so we're going to do probability of negative 1.19 minus the probability of negative 2.68. And I wish I could make it bigger for you to see the whole thing, but it's
We can
basically
see it.
just what I got written right there. So 11 so I need to have 4 decimal places, so it's going to go to there. And there we go. All right. Any questions on that? For A, we essentially, because it's to the right, we use 1 minus the probability of what we did before with the less than. Because that thing in the calculator and in the table, it only does what's to the left of. So that's why we got to use the complement rule.
Mr. Crew,
Mm-hmm.
that homework you just put on, that's on this what we going over?
What's that?
That assignment you just posted, that's on this here material for tonight?
Yeah, this is the last thing in chapter 11. Why?
Okay.
I got it in there just because that's the only way for me to access the problems. That's not for you to do unless you want it, but I'm not assigning it.
No,
It's assigned.
in Alexa, it say we got homework to do at 11 something
Well,
tonight.
like I said, is unless it's this, if it's this, then you can ignore it because I'm going to delete it as soon as we get out of here. It's
Oh,
just that I put this specifically together for this lecture, and that's the
Oh.
only way I can really do it is to create an assignment because I can't
okay.
go to
I understand.
Alex and navigate. So I
Um,
got to create an assignment to do it.
okay.
But don't have to worry about this. I'm going to delete it.
Okay.
All right. So let's see what else we can get into. There's another one over here. Okay, we use that one, the empirical. All right. So that's pretty much how the 11.7 works. 11.8 is really the same material. It's just they called it applications. And the only thing that's different is we have to calculate a z-score. So this is pretty much the same thing, but let's go ahead and do it. It's what we looked at with the first one with the big curve. It's basically the same thing. It's just that we don't have the visual. So, oh, I know what I was going to do. All right, so 99.7. I just need to show you something before I forget it, the z-score. And I'll talk about that in a second. I just wanted to bring it up, make sure I had it. All right. So now 99.7. So what we're going to do is we're going to take the mean. That's the mean. And we're going to take the standard deviation. And just like we did on that first one with the picture, we're going to add 3 standard deviations. Same old thing. So we're going to take 5.2 and I'm going to store it in there. And I'm going to take 19.0 plus recall. So there's 1 standard deviation, but it's 99.7. So we need 3 standard deviations. There's 2 standard deviations plus another one. So then this right here would be 34.6. I added 3 standard deviations. Another way you could look at it is if you take that and multiply it times 3, you get 15.6. And then if you add 15.6, to 19. See, you get the same number. I'm just doing it one at a time just to show so you can see where the 3 comes from. Now, that's 3 standard deviations. Oops, there's the 3 standard deviations, 5.2 times 3. Now, to save time, I'm going to take 5.2 and from it, I'm sorry, it's not, it's 19. There we go. And I'm going to subtract the 3 standard deviations. And that's what's going to go right here. So that's the endpoints for the 99.7 from the standard, from the empirical rule. All right, let's see how many standard deviations 8.6 is. I think we already know it because we did it before, but let's say 8.6 to 29.4. So I'm gonna, on this side, I'm gonna add we need one more because it's not up to 29.4, it's only 24.2. So there we got, that's 2 standard deviations. And we can also check it the other way. We can make 19 minus the standard deviation, 1. And then we're going to minus another one. And then that would be 8.6. So this is 2 standard deviations. That's 95%. Again, I'm going by the empirical rule. See, the top one, we went 3 standard deviations. So for this one, for the second one, we went 2 standard deviation, and that's what the 95% is. All right, so let's talk about the z-scores. To do the applications, the only thing that they add, thankfully, is just that they give us ones that we have to calculate the z-score for. All right. So remember that. We're going to need it here in a second. Okay, I think this is what we want. All right, so this is what we call an application, and there's a couple of things different. First of all, they don't just hand us the z-score. We got to calculate it. They do give us the fact that the mean is 625 days, 24 days, and standard deviation is 25 days. Now, this is just has to do with the gestation period of elephants. Okay. And so they're giving us the mean and the standard deviation for all elephants. And they want us to answer, let's see, hold on. Find the percentage of elephants. That's what this is. That are shorter than 675 days. All right. Well, we got to have the z-score. So we got to calculate it here. They're not giving it to us. And this right here is our x. This right here is our mean. And this is our standard deviation. So let me write this out. Z score is equal to x minus the mean. And then down here is the standard deviation. I'm just going to shorten it, so I don't have to write it out. And this is a fraction. So I'm going to put a line. So there's your formula for your z-score. So then I'm going to do z, and I'm doing it for 675. $675 is equal to, and that number goes first. We always want to subtract. We always want our number first, and then we're going to subtract our mean from it. That's what we're always going to do. The mean comes second. So this is 624. And what this does is what it says. It kind of standardizes it so that it's given in standard deviations, how many standard deviations it is from the mean. All right. So 675 minus 624, 51 divided by 25. So this is going to be 2.04. And now we're right back where we were before we got to the applications. Just what we were doing when we look up the z-values. Because now we got a z-value and it's shorter. Okay, so that means less, fewer, to the left of. So then when we look up our z-value, that's going to be the answer. Now we got to watch out here because in the applications, they're asking us something different here on the answer. Give your final answer to 2 decimal places. So for example, 98.3. So we got to do this as a percentage now. So I'm going to multiply this by 100. You can just, zip over to decimal places if you want to. So then this is our answer. 97.93%. All right. The applications, as far as I've seen, they always wanted in percent. So watch that, because in the initial section when we first started looking at this, they wanted it in decimal. So they wanted it in percent here. All right. Any questions? We got plenty of time. I can go back through or explain it, and I will do it just anyway, just to make myself happy. But what we got here, it's involving the, I'm going to go through it. I heard y'all telepathically. So it's just talking about the gestation period for elephants. So the mean is 625 days and the standard deviation is 25 days. So they want us to find the z-score for 675 and then find what's to the left or what's less than. So we create the z-score for 675 and we subtract, because we're using this formula here, we subtract the mean of 624 and we divide by 25, and that comes out to 2.04. All right. You can also get the calculator to do the whole thing for you by doing this. And then we can double check our answer. That's 2.04. Then I can use the calculator function for the z-score. and it's to the left. That's what shorter is. See the arrow on here is pointed in the less than direction. That's the default. That's what the table will hand you. What's less than 2.04. And that's what we want because 2.04 represents the 675 days. So 97, and then I multiply it times 100 so I can get it in percent. So 97.
Ain't I nodded again.
97.93%. All right. All right, let's see. We can do another one or two here. All right. So let's see what else we can do. There's another one in here. So this one says it's advanced, and I bet you it's going to be a between. It sure is. So this is has to do with the health of whale and dolphin populations. As part of the work, this group is modeling the lengths of blue whale calves that will be born over the next decade. For their model, Cetacean now, I guess, is using a normal distribution with a mean of 280 and then the standard deviation of 20. So those are the two numbers that I need for the data set. Now, because they're telling us that this model is normally distributed and it has a mean of 280 and a standard deviation of 20. Now, use the table or the ALEKS calculator to find the percentage. Okay, it's percentage again now of blue whales with a length between 269 and 299. All right, now, so what we got to do now is we got to do two z-scores. So 299 so I'm going to subtract the mean from 299. And divide by the standard deviation. And okay, and I'm going to go ahead and just calculate it out and write it, and then I'll do the next one, and then we'll come back and double check. So 299 minus 280. So 19 divided by 20. So that's the z-score is 0.95. And then the other one is the 269. So that's equal to 269 minus 280 over 20. So when you're working on this big problem, when we got two z-scores to calculate, you use the same mean and the same standard deviation. So 269 minus 280 divided by 20. So there's our two Z-scores. So I'm going to do it using the table, and then I'm going to come back and use the calculator to double check it. All right. So the top one, the big one, 0.95, we're going to look that up. And it's positive, so we got to make sure we get it in the right spot. So there we go. There's 95. So then between is equal to minus, and let's look up the other one. So we're going to look up negative 0.55. So we got to get the sign right. All right, so that's going to be, well, let's check it with a calculator. Wait, 8289 minus 0.291. And just a good thing about that one I was showing you is we could put all this in there and it would do it for us. We don't have to calculate the Z-score. But let's go ahead and do it with the ALEKS calculator. So that's 0.95 minus so see that? Same thing. Actually, this should be 8. But they'll give you, if you use a table, they'll give you credit for either one. But this one would have to be rounded off per this. And let me just show you over here what area it is you're looking for in this little doohickey. Let's say the mean was 280. The standard deviations was 20. And we wanted between 299. We'll put 269 and 299. So see that? Same thing. No matter how you cut it, you can do it several different ways, and you can see graphically that it fits. All right, any questions about anything that we looked at? I mean, that's pretty much it. You don't have to worry about all the different graph shapes and all that. But
Mr. Cruz, could I show you what I was talking about? Even when I went right there where you told me to go at, it's still not showing.
in ALEKS?
Yep.
Or what happens when you click on learn?
It takes me there, but when I try to do all the things that need to be done, it's still saying lock.
Well,
like
okay,
14.
That's what I'm saying is you can't I don't know why you can't do them individually, and you really shouldn't ever do that. You should just go through learn. If you go through learn, it will take you where you need to go.
That's
just
where
go.
I'm at.
And what are you saying?
But it's still saying lock. That's what I'm keep telling you.
In learn.